In this video, I'm going to show you how to know if a reaction is a redox reaction or if it's not. So for doing so, I'm going to show you 3 examples, and then we're going to go take a look at the oxidation numbers in each one, and based on that, decide if the reaction is a redox or not. So first thing is you have to know the rules for finding the oxidation number. So if you don't, I'm going to tag my other video over here so you can go over the rules and learn how to assign oxidation number to each atom. Otherwise, I'm just going to start putting the numbers right now. So for hydrogen, the number is +1 because we have 4 of that. In total, we have +4. That makes carbon to be -4. Oxygen here, it's 0. Again, we start with oxygen first, -2. So that makes carbon to be +4. And then we start from oxygen again, hydrogen this time first, which is +1. So that makes oxygen to be -2. And this way, after we look at the oxidation numbers, we can see that carbon, for example, is going from -4 to +4. Since the oxidation number is going up, that process is considered as oxidation. So now we can say carbon is becoming oxidized. And in oxidation, if you remember, there's always the loss of electrons. So there's electrons being lost for that process to happen. And then if we take a look at oxygen, we can see that oxygen, the number is going from 0 to -2. Therefore, we can say oxygen is becoming reduced since the number is going down. So this process is considered as reduction. And for reduction, we always have gain of electrons. And redox stands for oxidation and reduction. Therefore, because one of them is becoming oxidized and the other one is becoming reduced, this reaction is considered as a redox reaction. So let's take a look at the second example. Again, we do the same thing. We have to assign the oxidation numbers. So oxygen is -2. That makes Mn to be +7. Just keep in mind, I'm ignoring the 2 for balancing equation. I'm not going to use that. So my compound is technically MnO4-. And since oxygen is -2, 4 times that is -8. Therefore, Mn should be +7 in order for the overall charge to be -1. Then we do the same thing for this oxygen, -2. So in total, it's -8. So that makes carbon to be +3. Hydrogen, it's H+, so it's +1. Mn is +2. Starting from oxygen, -2, so carbon would be +4, -2, +1, and now we've assigned all the numbers, all the oxidation numbers to everything. So now let's take a look at the numbers. So Mn, manganese, is going from +7 to +2. So the number is going down. As we said, anytime the oxidation number goes down, that process is considered as reduction, which happens based on gain of electrons. And then taking a look at, let's say, carbon. So carbon, we have +3, and then it's becoming +4. So since the oxidation number is going up, that process is considered as oxidation. So we can say carbon is becoming oxidized. And again, because of that, this reaction is considered as a redox reaction. So last example, BaCl2. So we have to start from Ba, which is a metal group 2, +2. So that makes Cl to be -1. See here, one thing I want you to note is that we have SO4 on both sides. So it's not changing, and there's no more places for S in this compound. So therefore, I can just treat SO4 as just SO4 and just know that nothing changes about SO4, or I can actually assign numbers to sulfur and oxygen individually. I'll do both. I'll do it both ways anyway. So I'll start with Na, which is a metal group 1, which is +1. Oxygen is always -2. So based on that, we get sulfur to be +6. Now looking at the other side, same idea. Barium is metal group 2. Oxygen is -2. And again, as you can see, sulfur remains as +6. Na is in a compound, so it's +1. Cl is -1. And now if you look at all the numbers, Ba was +2 and it's still the same. Cl- was -1 and it's still the same. Na was +1 and it's still the same. Sulfur was +6, it's still the same. And oxygen was -2 and still is the same number. So no oxidation numbers going up or down. That means this is not a redox reaction. Okay, so just a little recap. In order to find out if a reaction is a redox or not, we have to assign oxidation number to each atom, either when it's in the form of an element or in the form of a compound. And based on that, taking a look and see if those numbers are going up or down. If the numbers change, that means it's a redox reaction. If they don't, that means it's not a redox reaction. And also you have to know the rules for assigning the oxidation numbers. So in this video, I'm just showing you as if you already know the rules. Again, if you don't, I have my other video tagged over here so you can watch and find out about the rules for finding oxidation numbers. All right, that was it for this video. I hope you enjoyed it. If you did, I believe you will also like my next video. I hope to see you there.